Hello. The question that is posed today is calculate the surface area of the portion of the paraboloid defined as z equals x squared plus y squared that lies inside the cylinder. X squared plus y squared equals 4. So the surface area formula is the double integral under that region D, where z defines the surface and d is the region where we're finding for that surface, the square root of the partial derivative of z in respect to x, square it, plus partial of z in respect to y, square it, and then add 1. Square root all of that and integrate in respect to the differential area dA. So first off, this problem would be notoriously difficult in Cartesian, so I am going to go ahead and convert it to polar, which thankfully is going to be okay when converting it over, because the partial x and partial y will just turn into partial r partial theta, and the dA will turn into the correct r dr d theta. Since it is inside the cylinder, x squared plus y squared equals 4, x squared plus y squared equals r squared, so r squared equals 4, so r goes from 0 to 2, and theta goes from 0 to 2 pi, giving us an integral like so. dr on the inside integral, d theta on the outside integral. For this problem, technically, it would not have mattered if I had done d theta first, then dr. It would still be the same integral, since there was no interdependency between r and theta for the bounds. Anyway, so we get that partial z partial r squared plus partial z partial theta squared plus 1, square rooted, r dr d theta. So we go ahead and find that the function as a function of r and theta only depends on r. So we do partial z partial r, and we get 2r. We square that quantity, and we get 4r squared, and partial z partial theta is 0. So our integral is now actually from 0 to 2 for r of r square root 4r squared plus 1 dr, and then d theta is from 0 to 2 pi. So moving on to the next page, we have that same integral, and we are going to do a nice convenient u substitution. Now, I chose my u in a very particular way so that we wouldn't get fractions later on, and I would just accept the fractions at the beginning. So I said that 4 times of u is equal to 4r squared plus 1. So that 4 times of du is equal to 8r dr, because you take the derivative of both sides and put their respective differential. So derivative of u in respect to u is going to be 1 times 4, so 4 du. 4r squared plus 1 derivative is 8r plus 0, so we just do 8r, and then 8r dr. Simplifying so that we can fully just replace the r dr in our integral that we're dealing with, we then get to here. Now, I could have rebounded the integral, but I thought that was more trouble than it was worth, so I decided on not doing that. So you simplify it, you move as many fractions out as possible, so the square root of 4 is 2. So that's why there is now a 4 outside. Now I did the extra 3 because I know that this is going to go to u to the 3 halves, and we divide by the 3 halves power. So the 3 halves here and the divide by 3 halves are going to cancel each other after the integral. So that way you can only deal with u to the 3 halves. But what was u? Well, we know what 4u was. So u would just be equal to the division. It is going to be r squared plus 1/4, as you see there. And that is going to be bounded from 0 to 2. That was my reasoning behind r equals 0 to r equals 2, so that we didn't rebound the integral in respect to u. So we start simplifying. We plug 2 into the upper bound, 0 into the lower bound, take their difference, simplify as much as possible, take a common 1/4 raised to the 3 halves power out. Since this one also had common denominators now, we can do that. And it turns into a 1/2 after applying the square root. And we cube it, turns into a 1/8. The inside terms, 16 plus 1 turns into a 17. The square root of 17 cubed minus 1 then simplifies to, with also simplifying the outside, pi over 6 times the 17 times the square root of 17 minus 1. And that is the answer, and the approximate answer to that would be, apologies, I probably should have had this ahead of time. So approximately 36.18, about. Takes a second to come to the page. There we are. 36.18. Rounding to 2 decimal places. Thank you, and have a good night.